Okay, so now I will be working on question 27. So the first concept I will be going over in question 27 is momentum and force. Okay, so I've explained this before, but the equation for momentum is P is equal to mass times velocity. So that is the equation for momentum. And then the equation for force is equal to mass times acceleration. And this is related to Newton's second law, the force equals mass times acceleration. Okay, so now I'm going to explain the relationship between these two concepts, momentum and force. Okay, so momentum is related to velocity and force is related to acceleration. So this helps us understand that basically the rate of change of momentum is equal to the force. So basically force is the rate at which momentum changes with respect to time. So force is equal to the derivative of momentum with respect to time. And you can also see that because since momentum is velocity, the derivative of velocity is acceleration, which is related to force. Okay, so that also means that the change in momentum is equal to the antiderivative of force with respect to time, or the integral of force with respect to time. Okay, so now I will read question 27. The graph above shows a variable force F that acts on an object as it moves along a straight line as a function of time t. What is the change in momentum of the object from t equals 2 seconds to t equals 4 seconds? Okay, so in this question, they're giving us a graph, of force and with respect to time. So that's the graph that they're giving us. But in this problem, we need to solve for the change in momentum of the object from 2 seconds to 4 seconds. So basically what we need to do is we need to integrate from 2 seconds to 4 seconds. So we need to take the antiderivative of force, which is momentum, and we can find the change in momentum from 2 to 4 seconds. So I am going to do that now. Okay, so I'll rewrite what I put here. Change in momentum is equal to force back to time from 2 to 4 seconds, because that's what it's asking for. And then now what I'm going to do is this graph here, you can't see all the points, but basically it has a slope of y equals x, or in this case y equals t, because the x is t here. Force is equal to time. So basically that's what I'm going to put up here because I'm finding the antiderivative of this equation. Okay, so then I'll go from 2 to 4 and of t dt. Okay, so now I'll integrate it. The antiderivative of just t is 1/2 t 2 squared. And we can check that because if we take the derivative of this, bring it down, this is just going to be 1t, and 2 minus 1 is just 1, so it would just be t. And then we're going from 2 to 4. So then we plug that in. 1/2 4 squared minus 1/2 2 squared, and that is going to give us 16 over 2 is 8 minus, this is 4 divided by 2 is just 2, and so we get 6, and it's going to be kilograms per meter second. So in conclusion, the correct answer to this problem is D, because basically when we integrate from 2 to 4, we find that the change of momentum is equal to 6. So this problem shows important concepts of how momentum and force are related. The derivative of momentum with respect to time is force, and so in this problem we're trying to find the change in momentum, and we can do that by integrating force.